So we are going to start the second unit, and the first topic in that second unit is the atmosphere distillation column. There are basic fundamentals, some basic things for the atmosphere distillation column will be discussed here. So let us start the first topic of the second unit. Atmosphere distillation column or atmosphere distillation unit, these are the few names, that is a nomenclature that we are using in the industry. So either you can say the atmosphere distillation column, sometimes atmosphere distillation tower, even the very common name is atmosphere distillation unit. This is one of the most common one, atmosphere distillation unit. Normally industries ADU shortcut, ADU is called as atmosphere distillation unit, and the more generalized form is the crude distillation unit. Basically CDU is called the crude distillation unit. So these are the few names that are being used for the distillation column in the refineries. And then few important points related with the atmosphere distillation column, and you might all know about, and it should be known to all of you. Let us take in a very brief way. For example, the distillation column, the atmosphere distillation column, the pressure is normally the atmospheric pressure. That's why we call it as atmosphere distillation column. And as far as the feed is concerned, the feed is basically the crude oil and a mixture of a large number of hydrocarbons. So that's why this is a very unique type of, because we don't know exactly the number of components in this one, as in contrast with the conventional distillation column, where we know about the number of components available in that feedstock. The product, as far as the product is concerned, there are multiple products, not only from the top and bottom, but the side products are also there. That is a new thing as compared to the conventional one. In the atmosphere distillation column, the pressure, as I have told you, that the name is atmosphere distillation, it is at atmospheric pressure, but in actually it is slightly higher than the atmospheric pressure. In fact, there is one reference pressure that is taken normally at the condenser level. So that's why if you calculate the pressure drop at each and every section, so you will find that the pressure inside the column is slightly higher than the atmospheric pressure. The next point that we all know about the temperature, there is some limit in the temperature of the atmosphere distillation column, and it has been observed that the maximum temperature that can be possible is 370, 360 or 370 degrees Celsius. You cannot go beyond that temperature, otherwise there will be a problem of cracking, and if the cracking of hydrocarbons are taking place, then coke will be formed, and that coke will basically degrade the products, the lighter products also. So that degrade and that make the low quality products, that is undesirable things. So that's why we have a limit over the temperature. So after going through the basic one, let us look about the graphical representation of the atmosphere distillation column. So we all know it is simply a cylindrical vessel in which either the packings are there or the trays are there for the mass transfer. And as far as the feed is concerned, normally the crude oil is being charged into the atmosphere distillation column, but there are a very specific point in this one, that is the location of the feedstock. Normally the location of the feedstock is at the bottom due to the reason, and the important reason we'll discuss, because we know that in the distillation column, up at the upper of the upper portion of the feed is known as the bottom portion is stripping section, and upper portion is rectifying section, is known as rectifying section. So because there is no stripping section in the crude distillation column, that's why we don't need a bottom section. That's why the feed is entering into the bottom, a very lower section of the column, although not exactly with the lowest one, but lower section of the column. But feed is not charged at a normal temperature, it is preheated with the help of the furnaces. There is a preheating, and the maximum temperature, as I already discussed, that reaches up to the 370 degrees Celsius. After the feed charge into the column, there is continuously mass transfer going on, vapor liquid interactions are going on, then we can recover the top products. Normally the top products are the vapor and liquid mixture. Vapor, a very lighter one, for example C1 and C2, these are the lighter one that cannot be condensed at the conventional condensers. That's why that is available in the vapor phase, and C3, C4 sometimes it can be available in the liquid phase. So it is a mixture of vapor and liquid one. But after that we can recover the side products So there is one problem in the side products when you are recovering it, that is the quality. The quality of the side products are not as per the desired one. Means their compositions are given that we need this composition, this boiling range of the product, side product from the column, but that is not coming here because of the lighter products available at that location. So we need a tuning of the side products. So tuning is carried out with the help of strippers. So normally 3 or 4 plate stripper are required here, where we have to go through the stripping of the lighter fractions so that we can obtain the desired product as a given by the specifications. So strippers are required for the side products, not only for the one. Normally we have go for the 3 and 4 side products. For all side products we require the stripper. So after stripper there is a bottom products. So bottom product, we normally, that is called the residue. So the residue is taken as it is, and there is no reboiler, because reboiler is required when the feed is charged in the bottom section and there are proper stripping sections in the bottom one. So because already the feed is charged at a sufficient temperature so that all the vapors are in the upper section, in the rectifying section, that's why we don't need the stripping sections. That's one of the basic reason behind the not availability of the reboiler. We don't have any lighter fractions in the bottom except very few one, and that can be taken out by the steam. We'll discuss it. Now the next one is the refluxes. Obviously we cannot think the distillation column without the refluxes. So refluxes are there, even where there are details refluxes are there, internal refluxes. We'll discuss in the other videos about the refluxes in the atmosphere distillation column. So as already discussed, that is the bottom steam. There is a concept of bottom steam into the atmosphere distillation column. This steam have a several basically purposes. The main objective of this bottom steam is to provide, to just take out some lighter fractions if it is available in the bottom product. So from the residue, these bottom steams are basically used to extract some lighter fractions. So that's why we have to provide 3 to 4 trays also, and that is why the feed that is taken here is charged into the bottom, but not at the lowest level. There are 3 to 4 trays are available that is used for the stripping of the bottom products. A very small fraction is being basically transferred into the vapor phase. So this is all about the atmosphere distillation column. Their basic functioning means how the feed is preheated and then it is charged into the column at the very lower section, and then bottom steamers are there, no reboiler are there, side strippers are there. These are the very new thing as compared to the conventional one. So that's an important thing, and in the next few videos we'll discuss about some other factors, and we have to look closer about it one, because in the second unit we have to design all these things. We have to go through the energy and material balance of all these sections. We have to go for feed sections, we have to go for the bottom sections, we have to go for the stripper sections for the energy and material balance. That's what we are going to do into the second unit. So thank you very much.